important. Inverse functions, because we'll be dealing with inverse functions soon, specifically logarithms and exponentials for inverses of each other. An inverse function denoted this f inverse. It undoes f. Whatever f does, it sends it back to x. Whatever f inverse does, f sends it back to x. So here's x, f sends it to f of x, f inverse sends it back. They're opposite operations. So y equals f inverse of f if and only if f of y equals x. That's what I mean by them undoing each other. Okay. Now, when you graph it, excuse me, we have a cat here. Okay, cat, excuse me. Get out of here. Oh, you didn't listen, did you? Okay, come on, cat. Here. Excuse me, the cat is being uncooperative. Sorry about the interruption. All right, now here. So if y equals f inverse if and only if x equals f of y, then here if we take a graph of y equals f of x, and the graph of y equals f inverse of x is the same of f of y equals x. And for some reasons have one. And so these two, this graph, this equation, and this equation, they're the same except we exchange x and y. Now we can do that by flipping through the diagonal. Flip through this diagonal. That exchanges x-axis and y-axis, and it changes the graph of f into the graph of f inverse. So for example, here's the graph of y equals x plus 1. Flip through this diagonal, which is incidentally is the graph of y equals x, and get this graph, the graph of y equals x minus 1. Here's the graph of y equals 2x. Flip through the diagonal, you get this graph, the graph of y equals 1/2 x, doubling and halving our inverse operations. This is the graph of y equals x cubed. And flip the diagonal, and you get this S-shaped graph, the y equals cube root of x. Now, trouble happens when we try and find the inverse of x squared. Here's a graph of y equals x squared. Flip the diagonal, and we get the graph of x equals y squared, but that is not a function, because a vertical line meets us at two places. You can think of it as a graph of two inverses. Here's the graph of y equals the square root of x. Here's the graph of y equals minus the square root of x. So it's not a single inverse, there's two of them. Now, the problem here is this is not a one-to-one function, meaning that it sends different values to the same value. 2 squared is 4, negative 2 squared is 4, so the inverse doesn't know where to send 4 back to, 2 or negative 2. So this is, we say that this is therefore not a one-to-one function. A one-to-one function is the one that sends different numbers to different numbers. So there's a visual test of it. Take the graph, and every horizontal line meets it just once, and that is a one-to-one function, and it has an inverse. Whereas this, a horizontal line meets it twice, and it's not a one-to-one function, and it does not have a single inverse. As to finding the formula as opposed to the graph of the inverse function, y equals f inverse if f of y equals x. So write f of y equals x and then solve for y, and you get the inverse function. In a sense, inverse functions are like algebra in general. We're sort of transposing f to the other side to get f inverse. For example, f of x equals 2x plus 4, what's its inverse? Well, if y equals f inverse and f of y equals x, f of y, we plug it in here, get 2y plus 4, that equals x, and now we solve for y. First subtract 4, 2y equals x minus 4, then divide by 2, y equals x minus 4 all over 2. So this expression, x minus 4 all over 2, is the inverse of this function, 2x plus 4. Now notice something here. Looking at 2x plus 4, what does it do to x? Well, it takes x, it doubles it, 2x, adds 4, 2x plus 4. Now this inverse function, what does it do? It takes x and subtracts 4. That's x minus 4. Then takes half of that, x minus 4 over 2. Here we have doubling, here we have halving, here we have adding 4, here we have subtracting 4. So this inverse function is opposite operations in the opposite order. So some examples. F of x equals x over 5 plus 4 over 5. Find the inverse. All right, so y equals f inverse of x means f of y equals x means y over 5 plus 4 over 5 equals x. Fine. Okay, multiply both sides by 5 and you get y plus 4 equals 5x. Subtract 4 and get y equals 5x minus 4. And that's the inverse function. F inverse of x equals 5x minus 4. Castanito, excuse me. Y f of x equals 4 over x. All right, it's inverse. Well, okay, so y equals f inverse means f of y equals x, means 4 over y equals x. And then if we take reciprocals of both sides, you get y over 4 equals 1 over x, and transpose the 4. Y equals 4 over x, and the inverse function is 4 over x. Here's a curiosity. 4 over x is its own inverse. Well, let's try this. F of x equals x cubed plus 8. Find the inverse. So y equals f inverse of x means f of y equals x means y cubed plus 8 equals x. All right, subtract 8. Y cubed equals x minus 8. Take a cube root. Y equals the cube root of x minus 8. So cube root of x minus 8 is the inverse function. Here we have f equals 2x cubed minus 3 to find the inverse. Y equals f inverse x. F of y equals x means, so plugging in a y here, we get 2y cubed minus 3 equals x. Solve for y. First add 3 to both sides. 2y cubed equals x plus 3. Then divide both sides by 2. Y cubed equals x plus 3 over 2. Then take a cube root. Y equals the cube root of x minus 3 over 2. And that is the inverse function. And again, in case of opposite operations in opposite order, this function takes x, cubes it, doubles it, and subtracts 3. This function takes x, adds 3, halves it, and takes a cube root. All right. Here f of x equals minus 2/3 x plus 3. Find its inverse. Well, okay. F of y equals x, minus 2/3 y plus 3 equals x. Subtract 3 from both sides. Minus 2/3 y equals x minus 3. Multiply by the reciprocal of minus 2/3, that's minus 3 halves. So y equals minus 3 halves of x minus 3. And after a little bit of manipulation, that's y equals minus 3 halves x plus 9 halves. And that's the inverse function. Okay. That concludes.